Throughout this video, we see how to solve a rational inequality. We start with an example. Here is the question. Solve the rational inequality x square plus x minus 2 divided by x square minus 3x greater than 0. To solve a rational inequality mean we have to find those value of x that will satisfy the given rational inequality. So how do we start? To solve a rational inequality, we have to follow some step. So here I am explaining the step, the solution. At first, what should we do? Whatever rational expression we have, on that rational expression, we first take the numerator and break it into the linear factor, and then we take the denominator and break it into the linear factor. So what I am trying to say, if we take the numerator, so the numerator is we have x square plus x minus 2. So this numerator is a quadratic. We have to factor it into the linear factor. So how do we do that? First, we have to write down the coefficient of x square, coefficient of x and constant term. So a is the coefficient of, so I am writing coefficient of x square. So what is it? It is 1 here in this case. B is the coefficient of x. So it is also 1 here. And C is the constant term. So constant term here is negative 2. Now what should we do? We first calculate A into C. So AC will be 1 into negative 2. So that is negative 2. Now what should we do? We will rewrite negative 2 as the product of two numbers T and S, such that this T and S we will determine such a way that the sum of that two will give you the middle term, I mean the coefficient of x square. So S plus T will be 1. We have to select T and S. Clearly, if we take T equals to 2 and S equal to negative 1, it works. So we can select T equal to 2 and S equal to negative 1. If we take the product of T and S, we get negative 2. And if we add them, we get 1. That is exactly coefficient of B. Now once we have this factor T and S, what we do? We will replace the middle part. So that is Bx here, 1x. That we can replace by Ts plus, so B of x will be replaced by T of x plus, I mean with the sign appropriate, S of x. So here in our case we have Bx mean plus x. That will be replaced by 2 of x minus 1x. I am writing x minus 2. So what should we get here? We get x, we can factor out, then we get x plus 2. So now what I did, I make group by taking first two term, then we factor out x. The remaining part will be x plus 2. Then from the last two term, same way, if we can group it, then again we can factor out negative 1. So we get here x plus 2. Now we have now two term, and from every term we can factor out x plus 2 here. So that if we factor out, then remaining will be x minus 1. So we completely factor the numerator into the linear factor. Now we go to the denominator. So first we have to factor numerator into denominator into linear factor. So that we are doing now. So what should we do? The denominator is x square minus 3x. Although it is a quadratic, but one thing is clear that from every term we can easily factor out x. because in every term we can see x appear as a factor. So we can factor out, so it will be x minus 3. That is the linear factorization of denominator. So the rational expression, this was the first step. So rational expression become now in this form x square minus 3x. This become x plus 2 into x minus 1 by x into x minus 3. Now in the second step, what should we do? We calculate the zero of numerator and denominator both. So here it is. So from numerator, what should we get? So if you can see that in numerator, zero of numerator, zeros of numerator, zeros of numerator are negative 2 and 1, because we have two factors. From here you get negative 2 and from this factor you get 1. Okay, and 0 of denominator. So that are basically 0. We getting here 0 for the factor x and 3 for the factor x minus 3. So for 0 we get 0 here, for this factor we getting 3 here. So these are the 0 of numerator and denominator respectively. Now this 0 will divide our real line into some subintervals, so that we first plot on the real line. So if we listed the zeros in the ascending order, then they looks like negative 2, then we get 0, then we get 1, then so 3. So here it would be negative 2, then we get here 0, then we get here 1, and then we get here 3. So this 4 number divides the total real line into 5 subinterval: negative infinity to negative 2, negative 2 to 0, 0 to 1, 1 to 3, 3 to infinity. Now on this each subinterval we will check the sign of this rational expression, and from there we decide which subinterval we take and which we will not take. So here I am writing interval. So here is the interval, then I am writing here the the selecting point. So we have to select point, selecting point, then we have determine the sign, so selecting point called p, determine sign of the rational expression, that let's say called this rational expression, we call it is qx, sign of qx, determined sign of q at the point phi, the selecting point phi, and here the decision. So decision mean we accept the interval or not that. So first interval that we have negative infinity to negative 2. So this is the first interval we have. Now in this interval we can take any number. For example, we can take here the number negative 3. If we take negative 3 here, then what should we take? So if we take negative 3 and put in the, so p is negative 3. Now we put it here, so what should we get? So we can see that. So here I am writing that we'll get, so we get here negative 3, a negative 3 whole square plus negative 3 minus 2 divided by, we get negative 3 whole square, negative 3 into negative 3. So we get here 9 minus 3 minus 2 divided by 9 plus 6, sorry, 9 plus 9. So we should get here 4 divided by 18. So here we are getting the positive, because this is a positive, so we get here the positive sign. So now see, we need the rational expression positive, so this is acceptable, so I put here the acceptable sign. Now next we should take the next interval -2 up to 0. Here, since we have strictly greater than 0, so in this case we have strict greater than 0, so we are not including the boundary point, I mean -2, 0, 1, 3, that we are not including. If you have here greater equal to 0, equality, if you have option, then you have to include the boundary point. Okay, so now for this interval, what should we do for this type of, so let me raise this one. Now when we taking the interval -2 to 0, so in this case what should we do? We have to select a point here. So -2 to 0, we can select -1. So here -1 we are selecting. If you select -1, what is the form then? So this will be -1 whole square plus -1 minus 2 by -1 whole square minus 3 into -1. So we get here 1 minus 1 minus 2 divided by, here it would be 1 plus 3. So we get here -2 by 4, which is less than 0. So this is negative sign. So if we put -1 in the rational expression, we get negative sign, so that is not acceptable. So now we move to the next interval 0 to 1. So if we consider now 0 to 1, this interval, so in this interval we have to select a point. So in between 0 to 1 we can select, let's say, 1 over 2. So if we select 1 over 2 and we put in the rational expression, what should we get? So then in that case 1 over 2 whole square, 1 over 2 whole square, and then plus 1 over 2 minus 2 divided by, in the denominator we get 1 over 2 whole square minus 3 into 1 over 2. So you can also put this in the factor form. Instead of putting here, just we can put in the factor form of the rational expression, I mean in this form. So 1 over 2 plus 2, then easily we can decide the sign without doing lot of calculation. So then 1 over 2, and here 1 over 2 minus 3. Now if you look at this is the positive expression, but this is the negative expression. This is positive and this is also the negative. So now in the numerator we get negative sign, total thing, and denominator total thing will be negative. So negative by negative, you should get here positive sign. So what should we get here? We get here positive sign. So this is acceptable. Now we move to the next interval, that we have 1, 2, 3. So if we look at this 1, 2, 3, this interval, then what should we get in this interval? 1, 2, 3, let me select a point, that is 2 here. So if we take 2 and put in the, let me put here the factor form, then we can easily decide 2 plus 2 and 2 minus 1 divided by 2 into 2 minus 3. So we should get here, this is positive, this is positive, this is positive, this is negative. So here in numerator we get positive, but in denominator we get negative. So total thing will be negative. So this is negative, so this is not acceptable. Now what should we move? So we move to the next interval that we have is basically 3 to infinity. So this interval if we take, then what should we get here in that case? So here it is that so if we take 3 to infinity, we have to select a point first here. Let me select 4. If we put 4 here, then what should we get? Then it would be 4 plus 2 into 4 minus 1 divided by, then we should get 4 into 4 minus 3. Now if you look at this expression, then you can see that this is positive, this is positive, this is positive, this is positive, denominator numerator positive, total denominator expression positive, so both positive, so the whole rational expression is positive. So this is positive, so it is acceptable. So now the general solution or the all solution will be, so the values of x, or you can write down solution is, we have to take -2 to -infinity to -2 this interval, and we also have to take 0 to 1 this interval, and 3 to infinity this 3 interval. So how we have joined them? So just taking the union sign, those are called the union. So this is the solution of the rational inequality. So let me go through very first what I did here. Whenever you have a rational inequality, what should you do? First you know the factor numerator and denominator. So then both numerator and denominator will have some zeros that you listed and write down in the ascending order. Then you put in on the real line. Those numbers will divide the real lines into sub intervals. On each sub interval you have to determine the sign of the rational expression by selecting a fixed point, and then you decide which interval you take and which you will not take, and then at the end you can list it all the acceptable interval. So this is like this. Thank you so much. Bye.